Our journey begins in the vast sugarcane fields, where advanced harvesters awaken. Precision engineering drives high-speed steel blades designed for effortless cutting. The base cutter slices through the thick stalks at ground level with surgical precision, ensuring maximum yield from every plant. Once severed, the heavy stalks topple backward, guided onto the machine's intake system. These massive machines traverse the rough terrain on heavy-duty tracks, compacting the dry earth beneath tons of steel. Inside the throat of the harvester, powerful feed rollers grip the cane, pulling it aggressively into the chopping chamber. Internal blades chop the long stalks into manageable billets, while simultaneously stripping away tops and excess leafy matter. Powerful extractor fans separate the lighter leaf trash, blowing it out the rear to decompose on the field. Meanwhile, the clean cane billets are conveyed directly into a haulage truck matching the harvester's pace. From above, the coordination is seamless, a continuous river of raw material bridging the gap between machines. Within minutes, the truck's cargo hold is brimming with tons of fresh cane ready for processing. Fully loaded, the transport vehicle breaks away, accelerating down the dirt tracks to join the logistics chain. It joins a continuous fleet, a lifeline of raw material streaming toward the processing plant. Every load must pass strict security and logistics controls before entering the mega factory grounds. Precision is key. The truck halts on a massive electronic weighbridge to record the gross weight of the delivery. Advanced sensors instantly calculate the payload, logging the data into the factory's central system. Clearance granted. The vehicle navigates to the offloading bay, known as the reception area. Massive hydraulic rams engage, tilting the entire trailer to a steep 45-degree angle. Gravity takes over. Tons of sugarcane cascade down into the massive feed table below. At the bottom of the pit, heavy-duty chains engage, slowly moving the mountain of raw material forward. The cane is spread evenly onto a wide rubber belt, preparing it for the cleaning process. High-pressure nozzles burst into action, creating a curtain of cleaning power. The jets blast away field mud and debris, ensuring only clean cane enters the factory. Contaminated wash water, heavy with soil, flows rapidly through the grate system below. Heavier contaminants like rocks and stones sink and are mechanically separated from the floating cane. Now pristine, the cane ascends the main incline conveyor, heading straight for the milling train. Before shredding, a kicker drum aggressively levels the mat of cane, ensuring an even feed. The cane plunges into the heavy-duty shredder, the first violent step of extraction. Inside, hundreds of swinging hammers rotate at breakneck speeds, obliterating the hard cellular structure of the stalk. What emerges is no longer recognizable stalks, but a fluffy, fibrous mass rich in juice. Conveyors rush this dense carpet of fiber towards the milling train for juice extraction. A powerful suspended magnet stands guard, removing any stray metal fragments that could damage the rollers. The fiber enters the maw of the first crushing mill, where the real pressure begins. Gigantic, grooved rollers exert hundreds of tons of pressure, crushing the fiber cells completely. Rich, dark green cane juice bursts forth, cascading down the rollers in a torrential flow. This raw, mixed juice gathers in collection troughs, the liquid gold of the sugar industry. The squeezed fiber, now called bagasse, travels to the next mill for further extraction. Hot water is sprayed onto the bagasse in a process called imbibition, helping to dissolve and release remaining sugar. Re-wetted, The fiber passes through a second set of rollers to squeeze out the last drops of sucrose. Specially designed drainage grooves in the rollers allow the liquid to escape under immense pressure. Juice from all milling stages merges into a single pipeline ready for purification. The remaining fiber, now dry and exhausted of sugar, falls away as bagasse. This byproduct is not waste. It travels directly to the power plant to fuel the factory. Inside the furnace, bagasse burns fiercely, generating the steam that powers the entire operation. Steam pressure climbs to optimal levels, driving the turbines and heating the process. Back at the juice line, the raw liquid passes over vibrating screens to catch coarse fiber particles. Tiny fragments of bagasse, called kush-kush, are trapped on the mesh and returned to the mill. The screened juice drops into an intermediate holding tank, darker and smoother than before. Powerful centrifugal pumps seize the liquid, driving it upward to the reaction towers. Chemistry takes center stage. A valve opens, releasing a precise dose of milk of lime. The stark white lime solution swirls into the dark acidic juice, neutralizing it instantly. Agitators ensure a perfect blend, raising the pH level to prevent sucrose loss. The treated juice is pumped through heat exchangers, initiating a rapid rise in temperature. Temperature soars to 105 degrees Celsius, superheating the liquid to accelerate clarification. The hot juice flows gently into the clarifier, a massive settling tank where gravity does the work. Inside, a mechanical rake rotates at a glacial pace, sweeping the bottom without disturbing the liquid. Impurities and lime flocks coagulate, growing heavy and sinking slowly to the tank floor. Above the mudline, a zone of brilliant clear juice begins to form, rising to the top. This clarified juice overflows gently into the collection waters, separated forever from the dirt. Meanwhile, the thick mud sludge at the bottom is pumped out to be filtered one last time. A large rotary vacuum filter sucks the remaining valuable sugar liquid out of the mud through a porous cloth. A fixed blade scrapes the dry mud cake off the drum. This nutrient-rich byproduct returns to the fields as fertilizer. The clear juice now enters the massive evaporator station to remove water content. Inside the first vessel, the juice boils vigorously under low pressure. Steam generated here isn't wasted. It travels through pipes to heat the next vessel in the series. As water evaporates, the volume decreases and the liquid thickens. The thin juice transforms into a viscous, rich syrup, marking the end of the evaporation stage. Heavy bubbles struggle to break the surface, popping with a distinct, thick sound. The finished syrup is pumped out of the evaporator station, ready for crystallization. For direct white sugar production, the syrup enters a sulfitation tank to bleach impurities. Sulfur dioxide gas bubbles through the syrup, chemically removing color compounds. The treated syrup is drawn into the vacuum pan, the heart of the crystallization process. Operators closely monitor the supersaturation levels through illuminated sight glasses. At the critical moment, microscopic seed crystals are injected to trigger sugar formation. Invisible to the naked eye, sugar molecules rush to bond with the seeds, starting a chain reaction. The crystals grow rapidly, turning the liquid into a dense suspension of solid sugar and molasses. This heavy mixture, now known as massacute, is ready to be discharged. The massive bottom valve swings open, releasing the batch. The hot massacute pours into the crystallizers, large U-shaped cooling tanks. Spiral stirrers keep the mixture moving, preventing the sugar from solidifying into a single rock. As it cools slowly, the crystals absorb more sugar from the surrounding molasses, maximizing yield. The cooled massacute is pumped to the centrifugals for the final separation. The basket loads, and the cycle begins. Slow rotation turns into a blur. Thousands of revolutions per minute create G-forces strong enough to rip the liquid away from the solid. The heavy molasses passes through the fine mesh screen, flung outward by the force. Inside the basket, the brown coating vanishes, revealing a wall of pure, sparkling sugar crystals. To achieve that pristine white color, a jet of hot water is sprayed directly onto the spinning crystals inside the centrifuge. In an instant, the remaining molasses is washed away, transforming the crystals from raw brown to sparkling white. Once spun dry, an automated scraper blade, known as a plow, descends to harvest the batch. The heavy blade peels the sugar off the basket walls, sending the wet crystals tumbling down to the conveyor below. At this stage, the sugar is still moist and extremely sticky, glistening like wet snow under the factory lights. A vibrating conveyor gently shakes the pile forward, feeding the wet sugar into the drying system. The sugar enters a massive rotary dryer, a long rotating drum designed to remove all remaining moisture. Inside, a powerful blast of hot, filtered air is blown against the flow of the sugar. Internal lifters scoop the sugar up and drop it through the hot air stream, creating a cascading curtain of crystals. As the crystals dry, the moisture turns to steam and is immediately sucked out by powerful exhaust fans. Now bone dry but still hot, the sugar flows directly into a cooling drum to stabilize the crystals. Conditioned cool air passes over the tumbling sugar, bringing it down to room temperature to prevent caking. The cooled sugar is then fed onto a stack of vibrating screens to sort the crystals by size. Any clumps or oversized crystals are caught by the top mesh and removed for reprocessing. Only crystals with the perfect standard grain size fall through to the collection line. The result is a stream of pure, uniform white sugar, ready for the final safety checks. A high-powered magnet sits over the conveyor to capture any microscopic metal particles that might have entered the stream. Long inclined conveyors now transport the finished sugar up to massive storage silos. Inside the silo, thousands of tons of sugar form a white mountain, waiting to be packaged. Gravity does the work here, feeding the sugar from the silo bottom into the packaging hoppers. In the packaging zone, a robotic arm swiftly picks up an empty sack from the stack. Mechanical clamps grip the bag and snap it open beneath the filling spout. A high-velocity stream of sugar fills the bag to the exact preset weight. Sensors cut the flow the moment the target weight is reached. The filled bag drops onto the belt and travels immediately to the sewing station. A high-speed industrial sewing machine zips across the top, sealing the bag in a fraction of a second. An automatic blade snips the thread, completing the individual package. Every single bag passes through a final metal detector to ensure absolute safety. At the end of the line, a heavy-duty robot arm lifts the bags as if they were feathers. It stacks them in precise interlocking layers on a wooden pallet. An automated wrapper spins around the stack, securing it with clear plastic film for transport. Once wrapped, a forklift scoops up the heavy pallet. The sugar is moved into the vast storage warehouse. It is carefully placed on high bay racking, joining thousands of other tons of inventory. Day and night, the warehouse fills up, a testament to the factory's massive output. Meanwhile, in the quality control laboratory, strict testing ensures purity. A technician collects a sample directly from the production line. The sugar is dissolved in distilled water to check for solution clarity. A spectrophotometer measures the precise color grade, ensuring it meets international standards. Crystal structure is examined under a powerful microscope. Close up, we see the sharp, defined edges of pure sucrose crystals. Besides industrial sacks, the factory also packs smaller bags for retail. Continuous rolls of printed packaging film feed rapidly through the system. The film is shaped into a tube to create the 1 kilogram bags we see in stores. Sugar is dosed precisely into each pouch. Heated jaws clamp down to seal the top and bottom of the bags simultaneously. A sharp blade separates the sealed bag from the continuous roll. The bags drop directly into shipping cartons. Automatic tapers seal the cartons shut. Another robot handles the heavy lifting, palletizing the boxes for distribution. The factory never sleeps. Production continues through the night. The distillation towers glow against the darkness, a beacon of industry. Clean steam rises into the cool night air. The conveyors never stop feeding the beast. Trucks continue to arrive around the clock, ensuring no downtime. Massive gears turn endlessly, driving the crushing mills. Nothing is wasted. The dark molasses separated earlier flows into dedicated storage tanks. It is shipped off to be used in producing alcohol, yeast, or animal feed. The filter mud, rich in organic matter, is returned to the fields as natural fertilizer. Water evaporated from the cane juice is condensed and recycled back to the boilers. This closed-loop system minimizes water waste, making the factory incredibly efficient. The entire operation is monitored from a central control room.
Analyzing the data now, it seems localized.
Digital control systems visualize the flow of every drop of juice and grain of sugar. Engineers fine-tune pressure and temperature to maintain peak efficiency. As morning breaks, the shipping bay comes alive. The massive doors roll up, flooding the floor with sunlight. Container trucks back into position, ready to distribute the sugar globally. Forklifts efficiently load pallet after pallet into the steel containers. Once full, the heavy doors are swung shut and sealed. The cargo begins its journey to markets and homes around the world. From the fields to the factory, and now to you. Driving past the very fields where the process began. A journey of transformation from rough grass to pure crystal. Finally, the product reaches our tables. A simple ingredient that sweetens our lives. It dissolves instantly, leaving only the taste. Pure, crystalline energy. The result of nature's sunlight and human ingenuity. Stored by the ton, ready for the world. This is Mega Factory Sugar Production.